myself, Cindy Namaste, from CSE third year. So, as a part of my machine learning and techniques laboratory, experiment number 7, implementation of fuzzy Siemens clustering. First, we look into what is fuzzy Siemens clustering. Fuzzy Siemens clustering is an unsupervised machine learning algorithm used for data clustering where it allows a single data point to belong to multiple clusters simultaneously, with varying degrees of membership. Unlike traditional hard clustering methods such as k-means clustering, which has strictly assigned a point to one group, FCM is a fuzzy clustering technique that assigns a membership value ranging from 0 to 1 to each cluster for every data point. So as a part of an experiment, first we are going to import the dataset and necessary libraries which is pip install fuzzy CMS, and handle the missing values, standardize the data, apply fuzzy Siemens clustering with different cluster sizes, and evaluate the clustering performance using metrics like Silhouette score. Finally, we will visualize the clusters and centroids using Matplotlib library. First, we are going to import the necessary libraries such as pipinstall fuzzy Siemens. And next, we are going to import the dataset which is given as driver FCM CSV, and then we are trying to retrieve the first 5 rows of the dataset. Next, we are going to handle the missing values using fill now. Now we are going to handle the missing values, whereas this step replaces the missing values with mean of each column. This ensures that no errors occur during the clustering. And then lastly, we are going to print the missing values. Next, we are going to standardize this data using standard scalar in the dataset, where standardization scales all features to the same range. It ensures that no feature dominates due to larger scale. So we are importing standard scalar from pre-processing, and then we are going to standardize the data and fitting the data. And then these are the values we get after standardizing the data. Next we are going to initialize the data where the cluster range are from 2 to 6, which is nothing but 2, 3, 4, 5. And then next fuzzy Siemens parameter m is equals to 2, whereas higher value will leads to more overlap between the clusters. Next maximum iterations will be 150. And then later we are going to visualize this input features in using matplotlib library. We are going to use scatterplot, and then we are going to visualize the data which we have been given, the features, the scale data from all the rows and zero column, and all the rows and the first column. This is the output we will get, comparing with the feature 1 and feature 2. Next we are going to perform the FCM clustering with different number of clusters in a group, where we run FCM clusters for the sizes from 2 to 5. So we are going to measure this using Silhouette score. So we have initialized the Silhouette score and then values. Next we are going to iterate in the range of 2 to 6, which first the model is defined where FCM, the clusters are in the range of k, where k iterates from 2, 3, 4, 5, and then maximum iteration it goes to up to 150. And going to fit the data, the predicted would be stored into the labels variable, and then the score which we would get will be computed is nothing but Silhouette score, and then we are going to add that values using append method into the variable which you have created. And for cluster 2, these are the label values, and this would be the cluster score. For each, and it would iterate up to the range of 6, which is nothing but up to 5, 2, 3, 4, and 5. So here we get 5 clusters: label, Silhouette score, and partition coefficient. Where next we are going to plot the Silhouette score curve using Matplotlib. So as we have seen from earlier, cluster range would be from 2 to 6 as defined above. We are going to plot the graph between Silhouette score and number of clusters, and the graph would be increasing and then decreasing. Next we are going to evaluate the performance of the clustering, where partition coefficient, which is nothing but higher the partition coefficient, leads to better clustering. And partition entropy, which is nothing but lower the partition entropy leads to better clustering, which is inverse proportion. So from the performance metrics we have got, and in clustering is nothing but 2 to 6. Iterating, we are differentiating the Shilherd score and the PC. Next, we are choosing the model with optimum number of clusters. To select the best model, we are going to choose the model with highest Shilherd score, and that gives us the optimal number of clusters. So highest Shilherd score would be for the cluster k is equals to 4. So the best optimal cluster would be k is equals to 4. Next, we are going to visualize this cluster using scatter plot, iterating through the range again, FCM. For the cluster 4, here we are going to find the distribution of data in the cluster k is equals to 4. So for that cluster, we are going to visualize the graph that how these data points are interconnected throughout all the clusters, and the graph would be outputted like this. And next, we are going to display the cluster centroids. So for that, we are going to take the center points of this cluster which have been pointed, and from that we will get the cluster centroids. Next, we are going to visualize the clusters in table, which is we are going to look into the next step. So at the very last, we are going to import the overall classification, whatever we have done using FCM clustering, into the FCM output.csv file. So this CSV file, as you can see here, this was the overall classification report which we have got the after implementing the algorithm in this. So now we are going to visualize this output which we have got in the CSV file, importing it in Tabula, and then we are going to visualize how it actually looks in a data visualization table. So this is a plot which has been plotted using the CSV file which we have got from the previous thing. So this CSV file from the measures which we have taken here was from the CSV file we got mean, distance, and some measures. So using these measures we are going to plot x and y, and then using this cluster variable keeping into the color categorical variable. So as you can see here, fuzzy C means it actually shows how it works. So looking at this data point, there are two clusters classified here, and if you go through this, here you can see parameters such as mean distance day, count, cluster, and mean on speed. So here we can actually classify the data points, which is done using scatter plot. So this is how this experiment works, and this is a tabular visualization of the fuzzy Siemens clustering which have been implemented. Thank you.